Lotte Coelmont, KU Leuven.
Okay, so my title, I will introduce to you a novel vaccine platform technology. Okay, so the live-attenuated yellow fever virus vaccine is one of the most safe and effective vaccines used currently. It, however, also faces several drawbacks, such as the need for a cold chain, which is actually quite a hurdle in remote and tropical areas. It's produced in embryonated chicken eggs. It needs a very expensive quality control, and it still depends on a needle injection. This resulted actually in an insufficient coverage worldwide against yellow fever, which is dramatically exemplified by, next slide please, the yellow fever virus outbreak in Angola and Congo this year. Okay, so we developed a novel vaccine platform in which we cloned the genome of the yellow fever vaccine into our proprietary back shuttle vector. By combining, wait, next step, okay. So by doing so, we combine actually the advantages of a DNA vaccine with those of a live-attenuated vaccine. So we use a DNA plasmid by which we can induce replication to very high yields in bacterial cultures. No cold chain is required with this DNA plasmid, which is of course a major asset, and it can be administered needle-free. We still, on the other hand, use the genome of the commercial yellow fever vaccine, and this warrants a very high immune response. Now, how does this work in vivo? Next slide, please. Well, I first depict the normal route of a live-attenuated vaccine. Next slide, please. So the attenuated viral particle is injected, it enters the cell, it uses host factors to replicate and emit in the end viral particles, which will result in a high immune response. Now the difference with our technology is that we inject, next slide please, the DNA plasmid by means of a jet injector. So the plasmid is actually blown into the skin. The plasmid enters the nucleus of the cell. Next click. There, the yellow fever vaccine genome is transcribed, launched, and it follows the same route as the live-attenuated vaccine in the end, so still warranting a very high immune response. Next slide. Now the beauty of the yellow fever genome is that it can be used actually as a platform to modify and express foreign antigens by swapping or by insertion. So several antigens can be inserted, such as those of Ebola, rabies, influenza, but also in a therapeutic setting against cancer and hepatitis. Thank you very much.